Hi, my name is Kate Calvin. I'm NASA's Chief Scientist and Senior Climate Advisor. Thank you for the opportunity to speak today. I'm going to talk about how humans are changing Earth using a NASA perspective, focusing on NASA research. One of the primary ways that NASA studies Earth is through space. We have more than 24 satellites and instruments in orbit, including several on the International Space Station, that are continually monitoring our planet. We've been monitoring the planet for decades, so we can see both the state of Earth today as well as how it's changed over time. And we're looking at multiple aspects of Earth, so we can see things like vegetation, clouds and precipitation, carbon dioxide, and much more. Just as an example, we have a series of satellites called Landsat. The first Landsat observations are from 1972, so we have more than 50 years of observations from this satellite series. What Landsat shows us is land use and land cover. So it can show us where there are trees, where there's snow, crops, urban areas, deserts, lakes. And since we have more than 50 years of this data, we can see how all of that has changed over time. So when we look through those time series, what we see are things like urbanization. Our cities are getting bigger. We're also seeing declines in forest area in some parts of the world. And we see changes in the size of some lakes. One of the things we see when we observe the Earth is climate change. So this animation is showing temperatures. It's using surface temperature data set, but it's going to show you temperature change over time, starting in the late 1800s and working its way through today. 2022 was tied for the fifth warmest year on record, and collectively, the last 9 years have been the warmest since modern record keeping began. We're seeing more warming over land than over ocean, and more in higher latitudes than lower latitudes. It's not just temperatures that are rising, though. There are other impacts of climate change that we're seeing along with those increases in temperature. So we're seeing declines in Arctic sea ice, increases in sea level. We're seeing more extreme events like heat waves and wildfires. And we're seeing changes in the water cycle, including more heavy precipitation events and in some regions, more drought. And I'm going to talk through a little bit more of those later in the presentation. These changes that we're experiencing, what we know about from science is that many of these impacts will either become more intense or more frequent or both as warming continues. This figure is from the IPCC's most recent report. So the Intergovernmental Panel on Climate Change assesses the state of the climate literature every several years and puts out reports summarizing it. And what this particular figure is showing is the hottest day temperature change at different warming levels. 2022 was about 1.1 degrees Celsius warmer than today. This is showing this hottest day temperature change at 1.5 degrees Celsius, 2 degrees Celsius, 3 degrees Celsius, and 4 degrees Celsius. And what you can see is these extreme heat events increase with future warming. We know what's driving the warming we're experiencing. So human activity and principally greenhouse gases have warmed our planet. This animation is of carbon dioxide concentrations globally. The colors are indicating the source of those emissions, so brown colors are fossil fuels, greens are more from land. We're also showing some of the what's called carbon sinks. So when you see the flashing over the southern hemisphere, that's where carbon is being absorbed. So some of the carbon is absorbed by oceans and land, the rest remains in the atmosphere and traps heat, leading to warming on our planet. We can take this information on carbon dioxide and convert it to information about emissions of various sources of carbon dioxide. So this particular graph is showing fossil fuel emissions. It's the annual average emissions between 2015 and 2020 by country. And so we can look at that and see where the emission sources are coming from. This is just an annual average for most recent years. If we were to look at this over time, what we would see is some countries have emissions rising, some countries have emissions falling, but overall, global carbon dioxide emissions are continuing to rise. And with those rises in emissions, we're seeing increasing warming. What we know from science is that warming will continue as long as carbon dioxide emissions are positive. Carbon dioxide isn't the only greenhouse gas. So this is an animation showing you methane and what you can see where the sources of methane are around the world. Methane has different sources than carbon dioxide. So it comes from things like agriculture, oil and gas, landfills, and wetlands. Those are some of the sources of methane. But methane is also a greenhouse gas and traps heat. Per ton, it's more potent than carbon dioxide. It also can lead to air quality concerns around the world. Just about a year ago, NASA put an instrument on the International Space Station that will help us identify methane. So this is an image from that instrument. The instrument is called EMIT. EMIT was actually designed to measure mineral dust. So mineral dust are these fine particles that reflect or absorb sunlight depending on their color. EMIT's goal is to map those, but the science team realized they can also observe methane using that same instrument. And this is an image of that, a methane plume over the southwestern US. And this information is made publicly available so people can use it to inform what's happening where they live and take steps to address those emissions. So the increases that we're seeing in temperature are leading to climate change impacts all around the world. And I want in the next few slides to walk through some of the impacts we're seeing and what we might expect in the future with increased warming. So first, what this slide is showing you is data from GRACE and GRACE Follow-On. So GRACE and GRACE Follow-On are a set of missions that use a pair of satellites, and they rely on gravity to measure mass change. So they can see things like changes in the mass of ice sheets. They can also show changes in terrestrial water storage, which we'll get to next. But what we're seeing is that with warming, we're seeing declines in the mass of these ice sheets. And so this is showing you both Greenland and Antarctica. The time series is showing you over time the total mass, but if you look at the individual maps of Greenland and Antarctica, you can see areas where we've lost a lot of ice, as well as the bluer areas where we've actually seen some gains. As ice sheets melt, that water runs into the ocean, and it's one of the contributing factors to sea level rise. So in this slide, we're showing you total sea level, and what you can see is that has increased over time. This particular chart is starting in the early 90s because that's when our satellite observations of total sea level rise begin, but we do have some tidal gauge information that goes back much further that is consistent with these observations. So sea level rise is driven by a number of factors, including ice sheet melt, like we just saw on the previous slide. One of the other drivers of sea level rise that we're experiencing is what's called thermal expansion. So as oceans get warmer, they take up more space, and that's contributing to sea level. We have a portal here. So this particular figure is looking at global mean sea level, but what you really want to know is what about sea level rise where you live? And so we have a portal on NASA's website, if you look for NASA sea level change, where you can click on different coastal cities around the world and see both how much has sea level risen in that community up until now, as well as how much might sea level rise in the future. And that's really important for planning to think about where we might go from here and how much more sea level rise you might experience where you live. So sea level rise is not the only impact. This is an animation showing us some of the extreme events. So I mentioned earlier that climate change is driving changes in extreme events. This particular animation is looking at wet and dry extremes. So as we're seeing increases in warming, along with that comes more heavy precipitation events, and in some regions more droughts, as it's shifting the water cycle. And what this animation is showing is an index of the total intensity of these types of events. So looking at duration, magnitude, and frequency of these wet and dry extremes. And so the blue dots are where you have an increase in a wet extreme, red are where you have an increase in a dry extreme. And we're seeing both around the world. So we are seeing both increases in heavy precipitation events and flooding, as well as increases in drought in some parts of the world. One of the other things we're seeing are impacts on hurricanes, and this has particularly been relevant in recent months, in weeks in the US. So this particular animation is looking at two different hurricanes. Over the ocean, you're seeing Hurricane Franklin, but we're actually going to zoom in on Hurricane Idalia in the Gulf Coast. And what this is using the Global Precipitation Measurement Mission to measure the precipitation from a hurricane. And one of the things we know from climate change is that we're seeing a larger proportion of category 3 through 5 hurricanes. So we're seeing more intense hurricanes and we're seeing more intense rainfall associated with that. And some of our satellite instruments and measurements can see both where the hurricanes are, but also how much precipitation is falling as part of those hurricanes. So that's a lot about the impacts we're experiencing today, but a lot of what people want to know is what's going to happen next. And so this is another figure from the most recent Intergovernmental Panel on Climate Change report that's looking at the future. And this is using warming. So in this particular figure, reds and darker reds are warmer years, and the blues and yellows are cooler. And what you can see here is that up until now, we can look at the warming, but how much warmer it gets in the future depends on the emissions. So there are different scenarios of how much more emissions we have in the future, and higher levels of emissions mean higher warming in the future. And we can look at what that looks like over time, and we can map out what we expect some of those impacts to be. But with increases in warming, we're expecting more impacts, and we expect more warming with higher emissions. So another question I often get is, well, what are we doing about it? And so I want to talk through a little bit about NASA's role in mitigation and adaptation. So what we do in response to climate change. We are a science and technology agency. So part of what we do is we develop technologies. We have a team, an aeronautics team. It's actually the first A in NASA is aeronautics that has been working for decades with the aviation industry to reduce the environmental impact of flying. They work in a few different areas. So one is in aircraft design. So if you look out the wing of your airplane next time you're flying, you'll see that the end of the wings curve up. That reduces drag, which means less energy use and less emissions, and that comes from NASA research. And that team is continuing to look at how can we design an aircraft so they use less energy and less emissions. We also work in the space of airport operations. So we have a project that's looked at how you can better time when you depart from the gate so that you spend less time waiting on the tarmac, which means that you have less energy use and less emissions. And so looking at how can we optimize the way airports operate in order to reduce the energy use and the emissions associated with flying. The aeronautics team doesn't just work in terms of reducing environmental impact of flying, they're also looking at how they can use some of their research and their tools to help address some of the impacts of climate change. So they've been doing some workshops with the firefighting community to better understand the challenges that firefighters face in addressing wildfires. And some of those challenges have to do with how you observe and deploy fire retardant. So in some parts of the world, we rely on aircraft to deploy fire suppressant. And you can only do that during visible flight conditions. So those planes can only fly if they can see where they're operating, which means they can't fly at night and they can't fly when it's smoky. So we've been working towards how can NASA technology help with that? In particular, how can uncrewed aircraft systems help us better observe and respond to fires? Everything we do at NASA is open source. So we have a big effort going on across the agency about open source science. So the data that I showed from all of those Earth observing satellites, it's already publicly available and you can get it on NASA websites. But what we're doing now is working towards making it more user-friendly and easy to use. So the data is not just public, but also that people have access to it and know what to do with that. And some of that involves us putting some of the tools and resources and making those publicly available in addition to the products. Some of that has to do with us moving data to the cloud so it's easier to use and you don't need a supercomputer in order to use that information. Some of it has to do with us putting more trainings out, including trainings in Spanish language so that we can access a broader audience. But throughout everything we do, we're trying to make sure that people have access to the information we do so that they can address challenges in their communities. As part of that open science initiative, we have just recently launched an Earth Information Center. There is both a physical space in the lobby of our building in Washington, D.C., as well as a virtual presence. This Earth Information Center is really designed towards engaging the public, informing them about what information we have, as well as making that information accessible to them. Because what we know is that people are making decisions that are impacted by climate change every day, whether it's a farmer deciding what crops to grow or a home buyer assessing flood risk. And what we want to do is make sure that what we know about climate is available to everyone else. And so we've opened this physical space in our lobby and we're building out our virtual presence on the web, making sure that what we know is available. So thank you for the opportunity to speak today. Protecting our planet and sharing the information we have about it with the world is part of NASA's vision, exploring the secrets of the universe for the benefit of all.